Good morning, students. Welcome to the statistics class. Today, we will learn something about normal distribution. Normal distribution, it can also be called as Gaussian distribution. Okay, we can call this also as Gaussian distribution, named after this mathematician named Gauss. So, this normal distribution is number one is I call this to be as a continuous probability distribution. Continuous probability distribution. What do you mean by this continuous probability distribution? So now again we need to go back to our basics. So there are two types of variables we come across. The two types of variables are discrete variables and another type is a continuous variables. So when we come across with this variables like discrete and continuous, now what are these discrete variables? If ever we have to speak about discrete variables, these variables have a range, very small range, and very few values it takes into consideration. Not only that, according to my understanding regarding these discrete variables, these discrete variables express are expressed only in integer form. They don't take the values as fractions or decimals, whatever it may be, students. If ever we speak about discrete variables, right, their range will be small, right, and they will take some few values, and also according to my understanding they all take integer values itself. What does that mean, integer values? By nature they take a whole number. Their values will never be expressed in decimal form or in fractions. What are those examples? Like number one, I can say it to be as if you speak about number of children per family per family. If I ask or if I ask you to get the data about number of children per family among 10 families, what are the answers that you may get? You go to a family, you get an answer saying that we have two children. Some other family you go, you say they get we don't have children, zero. Some may say one, some may say three, we say four. These are the things that they take the values, and these values are always expressed in integer form. These variables are always expressed in integer form. Nowhere you will be hearing a family member saying that we have 1.3 children or 1.2 children, because by nature these values can't be expressed in decimal form. Okay, so likewise, if I ask any footballer and how many goals you have scored, number of goals you have scored in some 5 matches, if you say, you may say, I have scored around 2 goals, I have scored around 3 goals, I have scored around 0 goal. Okay, 3 goals, zero, then I may say one or two, like this. He may give the answers. See again, these answers, whatever has been given, number of goals scored, can't be expressed in decimal form. These are the forms that it takes. You will never hear him speaking or saying that I have scored zero point 0.5 goals. I have scored 1.2 goals, because by nature you cannot take the decimal values. So like that, these values are discrete variables. And what about continuous variables? Continuous variables are those variables which can also be expressed in decimal form. They can be expressed in decimal form, students. What are those variables? Like heights, like weights, right? Like even marks, you can speak about marks, you can speak about income. Okay, all these are the variables which can be expressed in the form of decimals. So these variables, when we are, they can be expressed in decimals, their range will be very huge, students. Right? For example, if I speak about height, a person's height may be 150 centimeters. Okay, we'll start with the 150 as the lowest height. And if at all I ask another guy what would be your height, that fellow may say me, saying that I have a height of 150.01 centimeters, sir, he may say. Another one may say I have a height of 150.02. So what happens is, I have, for the next number to come to 151, I have to come across with 99 values. Then comes 151.00. Is it right? So if ever my range is up to 180, so how many observations if I have to mention it? It will be too much. So that is the reason why these kinds of variables, continuous variables, are always expressed in groups, like 150 to 160, 160 to 170, and these groups are called as class intervals. You understand this? Now, when we speak about this normal distribution as a continuous distribution, right, in all the previous distributions that we have studied, whether it is a Bernoulli, binomial, or a Poisson, or a hypergeometric, they are all discrete probability distribution. We were finding out probability of a one particular value. What is the probability of 2? Or what is the probability of 0? Or what is the probability of 2 or more? Or something like this we were doing. But here in this case, we have to find out, in this continuous variables, we have to find out what is the probability that the value will lie between 150 and 160. Now we are finding out the value may lie in the interval. Okay, what is the probability that the value may lie between 160 to 170? Right, we have to find out the probability. Now you can understand here the difference between discrete and continuous is, in discrete probability distributions we were supposed to find out probability of an individual variable, and now we are finding out probability of a continuous variable, or we are finding out a probability of an interval, a value lying in that interval. What is the chance that a particular value may take or may lie in an interval between A and B, or between A and C, or between B and D? Like that we need to find out. And that is what it is all about. So in nature, there are so many variables you come across, students, so many variables that we come across in nature. So what are those variables? I just wanted to just highlight and say to you is that those variables all, they form, or they are under, they follow this normal curve or a normal distribution, students. They follow this normal distributions, in the sense most of the variables that we come across, they have the tendency to be adopted as a normal variable. That is why this normal distribution is very much important for us to understand. Okay, so it is very much important for each and every one of us to make sure that we follow this um, normal distribution. So now, what is it? The most important thing for this is, it is the PDF. It's PDF. We call this as PDF, probability density function. And remember, when it is a discrete variable, we call it to be as probability mass function, and when it is a continuous variable, we call this to be as PDF. Okay, so the PDF of a normal distribution is given by this as f of x. F of x. Sir, why f? If you ask for why f, why can't it be p? Yes, it can be p, no problem. You can use it as p, but there should be a difference between discrete probability distribution and a continuous probability distribution. So because of the, to make it a different between continuous and discrete, to make some changes, so to identify whether it is a continuous or a discrete, so the term as f is being used, students. So we have this as 1 upon sigma into root 2 pi into e raised to half into x minus mu upon sigma the whole square, where the x has the range from minus infinity to plus infinity, and standard deviation will always be a positive value. I want you to go through this PDF once again. I read out for you so that you will understand about this. F of x is equal to 1 upon sigma into root 2 pi into e raised to half into into I could say e raised to half into x minus mu upon upon sigma the whole square. Okay, I'll write it here, students, once again. If you want, I'll write it here. 1 upon sigma into root 2 pi into e raised to half. I can put this in a bracket, x minus mu upon sigma, right, into whole square. Okay, upon sigma into whole square. That's by default, it's taking some x minus mu upon sigma. Okay, so now when you see about these things now, students, you see there are four constants that we come across. One is called as pi, okay, and the other one is called as e. These are what we call them as the mathematical constants. Why I say mathematical constants is because they have some value. You know, they have some value. What are this value? For pi, it is 22 by 7. You know it. And this is an Euler's constant. We have the value as 2.718, students. Okay, this is Euler's mathematical constants. Apart from that, when you see here, x is a variable which is ranging from minus infinity to plus infinity. We have another two constants that are mu, right? In bracket, I'll write it as mu, and another one is called as sigma, which is called as standard deviation. Okay, these two are called as statistical constants. These are statistical constants. These are the constants which are now which we are interested in, and these statistical constants are called as for this as parameters, students. For this normal distribution, it is called as parameters. That means to solve any problem in normal distribution, we should have mu and sigma, students. Mu and sigma are two important values that we need to find out. What are they called as? They are called as parameters. Okay, so in normal distribution, when we speak about what is the mean of a normal distribution or the expected value of x, what it is always mu, students. And what is the variance of that variable, normal variable? The variance is sigma square, and what is the standard deviation of it is just sigma, students. This is the beginning that you need to understand, students. First thing is normal distribution is a continuous probability distribution, and its probability density function is given this. What is continuous probability distribution? I had explained to you. And the probability density function, why it is called as a probability density function? Why? Because we are finding out a probability of a value lying in one particular area or in uh, one particular range or one particular class, right? So that is the reason why we call this to be as probability density function, pdf. Okay, and it is given by f of x. Why it is f is been given as, why not p? Because there should be a difference between probability mass function, there should be a difference between probability function of a very discrete variable and probability function of a continuous variable. That is the reason why we take it as f of x is equal to 1 upon sigma into root 2 pi into e raised to half into x minus mu upon sigma the whole square, where the range of x is from minus infinity to plus infinity, and sigma will be always a positive value. Here we see four constants, that is pi and e, mu and sigma. Pi and e are mathematical constants to it, which has some particular value. When we have a value of it, then we don't need to worry about those constants. Okay, but we only have to worry about those constants which don't have a particular value, and those constants are called as parameters of statistical constants, and they are the parameters of this normal distribution, and mu and sigma are the parameters of it. So for a normal distribution, students, when you speak about the mean is given as mu, variance is given as sigma square, and standard deviation is equal to sigma. So this is what we have it in the beginning, students. Not only that, you also have to understand regarding certain aspects, students. Okay, what are those aspects that I will explain to you? Number one is that examples. What are the examples that come under normal variant? Okay, how can you identify these are the normal variant? I told you in the very reason is that whenever you come across with any kind of a variables which can be expressed in decimal form, students, we can easily consider that to be as a normal distribution. So first one, you can see what are the variables that comes under, what are the examples that comes under: heights of students, or heights of soldiers, or heights of any person, any number of persons. That is what it is. We can speak about heights, we can speak about weights of a person, or weight of our apples, or weight about fruits, or weight about anything. Okay, weights which can also be expressed in decimal form. Then we can speak about marks, students. Marks of any student which ranges from 0 to 100. You can take any value between 0 to 100. It can be 22.5, it can be 23, it can be 55.5, it can be quarter marks, it can be right 0.75 marks. Marks can be expressed in decimal form, right? Then we can speak about the atmospheric temperature, students. Atmospheric temperature, right? Atmospheric temperature, we can express it in the terms of degrees Celsius. We can say it as 33 degrees Celsius, 34 degrees Celsius, 34.3 degrees Celsius, 36.2 degrees Celsius. Like that we can express the atmospheric temperature, right? Then we can speak about the rainfall, students. Rainfall occurred in a place. Rainfall also can be expressed in decimals, like they are like 2.3 centimeters, or 2.3 millimeters of rainfall occurred. All these kinds of things that we come across. Then we can speak about the income of a person. Income can be expressed, like you can say it in paisa also. You can express that income, or the expenditure, whatever it is. We can express it in the form of a decimals, income. Then we have, we can speak about a melting point or a boiling point. A melting point or a boiling point. Okay, so this also can be. Then we can also have something like cooling point. Cooling point, all these we have. Then we can have something called as an IQ, right? All these are the variables. The values of these variables can be expressed in the form of a decimal, students. So when they can be expressed in the form of a decimals, you understand these are the problems that can be written or solved by a normal using a normal distribution. Okay, so this is the beginning of this normal distribution, students. So keep it in your mind. Normal distribution is a continuous probability distribution, and all those variables which can be expressed in decimal form can be considered to be as a normal variables, and all those variables are here. That is what we have it. So in the next video I will be explaining about the features of normal distribution, which are very much important to us. Okay, thank you.